All right, so in the last lesson, we were able to implement the ability to upload a file from the web browser to our backend, which is our Java code, and we were able to confirm that we really were receiving the file because we got the file name and the file size, okay? And we also had to configure our application to permit us to upload larger files than 1 meg, okay? So we got all of that working, but now we need to actually do something with the files because we're not actually like storing it anywhere. We're just like receiving it and then it kind of evaporates into the mysterious internet ethers of our computer. So now we're going to actually save it someplace. So let's talk a little bit about our options for saving it. In my experience, there are usually a couple of different approaches that I will see teams use when dealing with uploaded files. They will either take that file and store it into the database itself, and when I say the file, I mean the data of it, right? So all the bytes. Or some teams may take the file and store it on the file system of a server or on a network shared drive, which is better. Something along those lines, okay? So I don't want to get too deep into it, but I've probably been on more teams where the file was just stored into the database. And sometimes that's for very practical reasons that I might mention in just a second here. But honestly, that has never been my favorite thing to do with a file. My problem with that approach is that while it certainly does work, it works just fine. I know that databases, for the most part, especially relational databases that are used in corporations, are never optimized for storing potentially lots of large binary data and files. They can do it. Every database vendor will say, oh, we can do that. You can store all of our data in what's called a blob data type. So remember when we learned in the database section about different data types like varchars and big ints and dates and things like that. So there are other data types that we didn't really look too much at, such as blobs and clobs. And these are data types that are meant to potentially store large amounts of data. Now, I don't know what they want to define as large. It's probably going to differ from one database to the other and how the DBAs, the administrators of the database, have configured the database as well. But there are data types that are designed in every single database there is, including H2, for holding on to large amounts of data. And so you very well could just map all of this. In fact, what we probably could have done is to go into our person class, and we might have modeled this field right here as an array of bytes, as a byte array, and then JPA would have figured out the right thing to do with that pretty much right away. And that might have been fine. We might have done that. But like I said, I'm not a big fan of doing that. I just feel that if you are comparing the database's ability to efficiently store and retrieve large amounts of binary file data versus a file system, I think a raw file system is going to win every time. And so my preference tends to be to store that kind of data in a file system of some sort. Now, in a corporate environment that's well managed and well implemented, chances are you'd actually be storing that data onto some kind of a dedicated network file system device of some sort where it can be replicated behind the scenes and it's really, really fast and all kinds of cool things. Anyway, so what we're going to do here is store our data on the local file system of the computer, not in the database. For now, at least. I think in one of my future courses, maybe for the next spring course or something, I will have to show you how to store it in the database as well, because like I said, that actually ends up being done, in my experience, more frequently than storing it on a file system. Oh, and one other thing I was going to mention now about the file system thing. So there is a very popular technology for application development and deployment. Really, it's more for deployment than development, called Docker. And for those of you who have no idea what Docker is, I will try to explain it in this way and say, imagine if you could open up a piece of software on the computer. And right now I'm running on a Mac, but imagine if I opened up a piece of software that allowed me to run Windows in a window on my Mac, okay? And it would actually simulate a PC running inside of my Mac, okay? Now there is software that does that. It's usually referred to as virtualization software. And there's even an older technology called emulation, okay? So there are programs that can do this. If you're fairly unfamiliar with these concepts, I will simply say that Docker is kind of like that. Although for those of you who want to be most technically accurate, I will simply say that Docker definitely doesn't emulate and doesn't really virtualize either. It more like puts a sandbox around something that appears to be a copy of its own operating system running inside of your operating system. And that's as far as I'm going to go with that right now. So anyway, Docker is an extremely common, popular tool for developers to write an application and then have it packaged up into something that you can think of as a virtual computer, which can then be deployed onto a server that hosts lots of virtual computer images, okay? And there is a technology that is probably the most commonly used for hosting all of these so-called Docker images, and that technology is called Kubernetes. So Kubernetes can be thought of as a Docker container manager or orchestrator, okay? And one of the things about using Kubernetes is that it can be configured to make file system storage available to Docker containers. And when I say Docker containers, I mean your application that has been packaged up into something that looks like its own dedicated operating system image, if you will. So you may hear me say Docker container or Docker image, all right? So anyway, Kubernetes can make file system storage like a C drive or some folder on a computer. It can make that available for use by a Docker container, which is housing your application. However, some organizations may be better at doing this or worse at doing this or may not configure it at all. And one has to be careful about writing applications that will live in a Docker container that are trying to write or read files to and from a file system that is made available to your Docker container. Okay, you got to be careful with that because sometimes these Docker containers can blink into existence and then out of existence and then back into existence again. And each time they may do that for various orchestration and management reasons, files that they may have written out to a file system may no longer be there. Okay, so if you write an application like this and it's trying to store these images somewhere, and then the application temporarily gets sort of, we'll call it moved by Kubernetes and then comes back into existence again or something along those lines, files that it had written out to the file system might not be there anymore. And like I said, some organizations will be better at managing this than others. And some may have rules that you just can't do this at all. So in those instances, developers might just kind of hit their heads and say, okay, you know what? We're not even going to deal with those kinds of ambiguities. Let's just store the files in the database and be done with it. And in those cases, if the organization that is managing the Kubernetes platform is not being very helpful with solving those kinds of issues, then yeah, I wouldn't really argue with the developers who, in that case, prefer to just save their files to a database or somewhere else. All right, so having said all of that, how can we do this? Well, the first thing I want to tell you is that if we're going to write code, which we will need to do, to save this file somewhere, I would strongly advise not to write that code in the controller, okay? So far, we've just been putting all of our code in the controller. And so far, that's been pretty much okay because we don't really have any business logic, because business logic would not belong in the controller here. So remember this diagram here where we talk about the service layer, and that's where your business logic goes. And then you've got the presentation layer, which should be handling, for our purposes, just all of the logic that's related to web stuff, like receiving the request and then getting the data out of the request and then storing it someplace, which usually in our case is storing it in the one and only domain model class that we have, which is the person, right? And then we do have a database layer now, which is our person repository, right? But currently we do not have this business logic or service layer here in the middle. So our person repository, which represents the database layer, is being injected or interacting directly with our web layer. And that's okay for right now, because we don't have anything in the middle and we don't need any. Now you will see some teams who will just create an artificial, I would call it artificial business logic layer, and it will have what I call pass-through methods that simply pass through whatever we're doing in the web down to the database. So in other words, like right here where we're calling person repository.save, what you might have seen on some teams is that they will create a class called person service, okay? And then the person service class will have a save method. And so you'd see them call person service.save person. So it would look exactly like this. And then if you drilled into the person service method, you would just see this line right here. That's understandable why they're doing it, because technically that is arguably good architecture. However, that person service save method is doing nothing at all. It's what I call a pass-through method, right? It's just passing through to the real thing that's doing the real work, which is the person repository method. And so in a case like that, if that person service.save method or the person service itself isn't bringing any value at all to anything at all, like you could just erase it and just do this and nothing would be better or worse, then you might want to rethink that. I'm just saying. Now, I've been guilty of following blindly that three-tier pattern to that degree myself, but I don't know. At some point, I kind of woke up and realized, you know what, this is maybe a little bit dumb. So something to think about. So anyway, now that we're going to save files, I think we may have a good reason to introduce another dependency on the people controller, okay? Now, actually, you could consider that the ability to store and eventually retrieve files to and from the file system is really another data access layer responsibility when you think about it, right? Because currently we are storing people objects to the database and then retrieving them back out and doing CRUD on them, right? Well, we may want to basically just do the exact same kinds of things with files, right? We want to be able to store a file somewhere and retrieve a file from that same somewhere, right? So we could consider that we could just create another data access class, right? And this one will simply work with the file system, okay? So let's see what that might look like. So let's see here. So we currently have a package called data, and that's where we put our person repository. So I don't know, let's see what this might look like. So let's create another class called file storage repository. Let's just do that. Now I'm going to make this as an actual class because we're not using Spring Data. Spring Data is primarily for talking to databases. All right, so let's see. We'll create this. I'll add that. Let's close that. All right. And let's just say that we're going to have a method called, let's see, I don't even want to think of the data type for right now. So let's say it's void, and it's going to allow us to save a file to the file system. I guess we could call it save. Yeah, let's do that. So save. Now, what will this method take as an input though? So now let's jump back over here to our controller and see what we're dealing with when we're using the save method. So we're receiving this multi-part photo file name object right here, right? This guy. Actually, you know what? I just realized something. I named this photo file name, but it's actually not representing the file name. It's representing the entire file, right? So actually, I think that should be renamed. Sorry about that. I just realized it. I like naming to be accurate and meaningful. So that's not really a file name, that's a file, photo file. Now, since I renamed that though, its name now no longer matches with what the request is that's coming in. Now, I could go into the HTML and change that, but I don't feel like doing that, to be perfectly honest. So what I'm going to do instead is come over here to the request parameter and now specify what that request parameter name actually is. So this here is called photo file name, okay? And we're gonna map that guy's value to this photo file. So that's just a kind of a technicality there. All right, so we have this photo file now, right, of type multi-part file. Now, let's take a look at where that multi-part file is coming from. So here's the import for the multi-part file, and it is part of the web tier from Spring Framework, which means that this class is intended to be used from the web tier perspective. So again, in our 3-tier architecture, that multi-part file class, as specified by the Spring Framework, at least according to its package, is considered part of the web tier. So this gives me pause because I might have considered taking that multi-part file object and simply passing it down into my new file storage repository. However, the apparent fact that that object and class appear to be somewhat tightly connected to the web tier makes me highly reluctant to allow web stuff to be utilized down here in the data tier. So you get what I'm saying here? Now, nothing's going to happen exactly if I choose to break that convention, if you will, and let the multi-part file thingy come down here into my database tier or database level or whatever. At least not right now. Nothing bad's going to happen. But let me explain one reason why you might not want to do that, okay? So what if I wanted to add another presentation layer on top of these 2 layers here, on top of the business and data access layer? So right now, we've got the web interface, and maybe we'd have a mobile client, which for the most part would look very similar from the perspective of these guys. That would look very similar to the web browser client. But what if I had a third presentation layer, which wasn't internet related at all, and it was like a local desktop application? Okay, so just a local desktop application. And do you know what I mean by that? So not running in the browser, not running on a phone or anything, but like a native application that runs on Windows or runs on Mac OS or something like that. Okay, and so when you open up a file to upload into this database, that file isn't being transmitted over a network or over the internet or anything like that. That file is just being saved in a directory or in a database on the same computer as the user interface and everything else. Okay, so it's all local. Okay, so in that case, multi-part file would not make sense. Multi-part file only makes sense in a web context, okay? You only need a multi-part file if you're transmitting data, multi-part form data over the web. But if you've got a local user interface written in Windows, C# or something like that, I don't know that that would make sense here, but Java actually has an API and a framework for writing local applications. In fact, traditionally, all Java IDEs, actually, let me use that as an example. Traditionally, all Java IDEs are written in Java. Now, I don't know if IntelliJ is written in Java anymore, but I'm pretty sure it used to be. And one of its competitors, Eclipse, as far as I know, that's still written in Java. So these IDEs would be examples of local desktop applications that are likely written in Java, okay? So if I wrote a program that looked like this, and I could go up to File, Open, and then, or File Save or whatever, and I could save a picture that I drew inside of this program, if you could draw pictures in here, and I could save that somewhere, and I had code that was allowing me to save that file, I would not be using this multi-part thing here because there's no web. I'm not using the web to open or save, files that I'm working with within this application. Okay, so I hope you understand that. So for that reason, it would probably be a bit inappropriate for me to pass this multi-part file object down into my new, what did I call it? File storage repository. Okay, that probably would not be appropriate. I probably want a representation of a file that has nothing to do with the web. All right, that's my point. So what I'm thinking is, first off, let's get a reference to this new repository into this controller here. So just as we got a reference to the person repository, we can get a reference to the, what did I call it? File storage repository, like so. And then we can let Spring inject that into this constructor. And I'm just gonna kind of come down here on a new line and reference and say this should be something of type file storage repository, just like that, okay? All right, and then the last thing we need to do, of course, is to actually inject our parameter into the actual field. So we'll do a this.file storage repository equals file storage repository. Okay, that way we're setting it on that field there. And just a quick reminder now, so Spring will see this one and only constructor of this controller class. It will see the data types that are being specified as inputs for the constructor, and then it'll check its own registry of beans to see if it has any beans of these type. And if it does, it will inject them onto this controller, or rather it will call this controller and pass in any beans that match this type. Okay, so that's how that's working. And some of you, if you look online at examples that do similar things, you might see references to using the @AutoWired annotation to do the same thing. But as of Spring version 4.3, I think it is, or somewhere around in there, you don't need the @AutoWired annotation for a specific situation like this one. Okay, so that's why I'm not using it, but it wouldn't hurt anything if I did. Okay. And so now let's jump over here to this file storage repository. And so if I annotate this class as a repository, then that will let Spring know that it should create an instance of this guy and then inject it into our controller, okay? The same way that it's doing with our person repository, all right? So that's one step. Then down here where we are saving a person, now just as we can save that person, we also could save the file, right? So we could do something like file storage repository.save. So now the question was, okay, so what are we actually passing into here though? So what I just got finished saying is we probably shouldn't be passing in this photo file thing directly, but we need at least the binary data of this photo file thing, right? So let me cut to the chase and say that what we can do is we can reference the lower level data. And by the way, we're also going to need the file name itself. So let's pass that in for sure. Okay, so we can pass that in as one of our inputs, and we can pass in multiple inputs on this method, by the way. In fact, let's get a little more space here for a little while, okay? All right, so we can pass that in, and then we can also get a representation of the binary data of our uploaded file without passing in the whole entire multi-part thing though. And one way that we can do this is by referencing this thing here called getInputStream, which represents a stream of bytes that themselves represent the uploaded file, okay? So that's what we can pass in, and maybe that is all we will need to pass in. Now, I'm getting a red squiggly because this method can throw an exception. So for right now, I don't even want to deal with that at all. So I'm going to let that exception just jump onto the signature itself for now. Might do something with it later, but for right now, I'm just going to add it there. And let's see. Okay, and so now I'm getting another red squiggly, which is just telling me that the save method that I started to write on here doesn't actually know how to accept these data types because I wasn't done defining the save method. So now I will let Java fix that. So I will just do an option return, and I will tell it to change the signature of the save method like so. And so then if I jump back onto this method. So now we've got a save method that accepts a string for the original file name and an input stream itself. And that is looking pretty good. All right, so now let's go ahead and just flesh this out really quickly so that we can be done with this lesson, because I know I'm having to explain a lot of things. So what we can do now is we need to save this input stream as a file on the file system. So the first thing we'll want to do perhaps is to decide where on our file system we want this thing to go. And what I'm going to do actually is I'm going to make that a variable that can be configured each time we run the program essentially. So where I want to store this file in my version of this program won't be the same place as where you may want to store it on your computer, okay? So I'm going to make a variable that will represent that storage location. So I'm going to make it a private string, and I will call it storage folder. And I'm going to use a cool little feature of Spring where I can have Spring inject a value that comes from the environment of the computer, okay? And if any of you know Linux at all, then you might be familiar with the concept of a path and exporting a path, or actually paths even exist in Windows, right? So, and there's even a path environment variable even in Windows, okay? So what I want to do here is I want to have Spring find an environment variable that I will define outside of this program as the location where files should be stored for this program, okay? And then Spring will find out what that folder is called and then inject the name of that folder into this variable, okay? That's what I'm going to do. So the way I can do that is by using an annotation of Spring called @value, and then quotes, and then a $sign, and then 2 curly braces. So this is a very common way of using kind of like variables and things that bind to stuff, okay? And I will name this variable storage_folder. And so what I am saying to Spring is, hey, Spring, I want you to find an environment variable called storage folder. Now, many of you may not know what I mean when I say environment variable, so I will explain that a little bit later, okay? But it's going to find something called an environment variable. That's just a variable that I can define outside of my program here, outside of this entire program. It's a variable that will exist within the scope of my whole entire computer, not just within this program. And as it's starting up, it will look for an environment variable called storage folder. And if it finds one, it will take whatever value I have bound to that variable, and it will inject that value down here. Now, this is an extremely common technique, again, particularly for applications that are being deployed to environments like Docker, okay? So using environment variables to configure how your application will work is probably like the most common pattern you'll see when dealing with Docker. All right, so that's how we will determine the folder. And so then what we can do is we can create a path, a path starting with that folder. And let me import that. So we'll create a path starting with that folder, storage folder, and then we will tack on the original file name. So if you're on Windows, for example, and your storage folder is C:\downloads or uploads or something, uploads, C:\uploads. And then the uploaded file name is called cat.jpg. So then doing this path of and sticking this on here would say C:\uploads/cats.jpg. So this is just going to kind of combine all of that together. It's a way to concatenate paths effectively, okay? So there's that part. And then just in case there's any weird symbols and things that shouldn't exist in this original file name, because this is coming from like the uploaded data from the browser. So just in case there's any weirdness there, we can tell this path object to kind of clean up any weirdness in the file name. And we'll do that by calling normalize, like so, okay? And so now we will have this path, and I'm going to capture that path and just call it file path, I suppose. All right, so that's step one. And then all we need to do is really just kind of save this input stream to this path. And there's a super nice convenient way to do that by calling files.copy. And so there's a version of it that can take an input stream and then a target path. And then it can take some optional inputs as well that I don't think we even need to care about right now. So if we call copy, and let me import that, and then pass in our input stream and then our file path, like so. Now this copy method throws an exception, so we will want to handle that exception now. And so what I'm inclined to do here is actually just select all of that and then wrap this in a try catch, so a number 6, like so, and keep going. Now, I want to do something with this a little bit later, but for right now, let's just finish this up. We're almost done. So we're going to copy that input stream to this file. So that right there will write the file to the file system. And that is all we need to get the basic functionality working, okay? Okay, and then let me explain a little bit more now about this mechanism here and environment variables. And I think I have a relatively concise way to explain environment variables. So in order to understand environment variables, you must first understand what is the meaning of environment. The most basic definition for environment in relation to application development is it's the computer that your application is running on. Now, in this case where I'm actually going to be starting up the application from within the IDE, you could possibly say that the IDE is the environment for the application as well. You could say that. But usually when we talk about environment variables, we're mostly just referring to the computer, okay? So environment mostly means computer for the sake of this conversation. So environment variables are really a nice mechanism to allow a computer to pass information into the application without the users of the application needing to pass that information in. And the information will usually be information that is somewhat specific to the computer that the program or application is running on, okay? So in our case, this makes perfect sense because I am running this application on my computer, which is a Mac laptop, and I'm going to be storing my uploaded folders into a particular folder in my home directory on my Mac. Okay, so that's going to have a very specific path. But if I were to pick up this application and deploy it onto a Windows computer, the path that I want to use would have to be different because Windows paths are different, right? So on this Mac, I might use /users/Terry/uploads or something like that. On a Windows computer, I might use something a little different, C:\\/ I'm not even sure that I remember offhand where home directories are stored on modern versions of Windows, but it would be a little different. And so those are two different environments which require two different paths for specifying where to upload things, okay? So it would be inappropriate to ask the users of my web application to specify where on the server that is running the application, which they presumably did not write, where they want the file to be stored. That would not be appropriate at all. That would be something that should be configured by the person who maintains the server, maybe working along with the person who wrote the software, okay? So that's a variable that may need to be changed from one computer to the next. So let's jump back over to the controller. Okay, so now that we've got all of this going, the only other thing I think we need to do is to define that environment variable. So you're probably wondering, how do we do that? There's a really easy way for us to do this. All right, so what I'm going to do now is first, let me get out of presentation mode for a minute here. And then I'm going to do a Control Option R, or an Alt-Shift F10 for Windows and Linux. And then I'm going to choose Edit Configuration. So this is where I can edit how the Spring application starts. And I've got this section here called Environment Variables, where I can define environment variables really easily. Now, this isn't the only way you can define an environment variable on a computer. This is just an easy way that IntelliJ allows me to do that for applications that I am running within IntelliJ. But in real life now, when you're deploying this application to a server or something, there are server-centric ways to do the equivalent of this. All right, so anyway, I'll click on this little button right here, and then I can click on the plus, and now I can define that environment variable that I just referenced. So I think I called it storage_folder. Notice that I'm using all uppercase, all caps. That is a common convention, and using the underscore, just like when we're creating constants in Java. And then I think for the value, on my computer, I'm going to bind this value to users Terry uploads. Now, don't just blindly copy that. Okay, that's an actual folder on my computer. So you go find a folder on your computer where you want your uploaded files to go. That's where I'm going to put them on my computer though, okay? And then I'm going to click OK and apply. And then I can close this. All right, and now I am likely going to need to restart because of that environment variable, like an actual restart. Okay, so if I come up here, I can click on that little restart button there, and I'm going to go ahead and do that. Now I'm going to warn you. Yeah, I was just about to say, I'm going to warn you. If Spring doesn't think that environment variable is defined, then when you restart Spring, it's going to complain immediately. And that's exactly what I'm getting here. Could not resolve placeholder storage underscore folder. Oh, okay. And I know what the problem is now. I need to start this up from within here the first time at least. So now that I've created this new change here, I think I need to actually click run from here. Let's see. Yeah, there we go. Okay, so I think now subsequently, if I were to stop this and start it up again, it would be fine because now it's kind of like a new configuration. In fact, it is a new configuration essentially. Yeah, so that started up. In fact, here, I'll just test that out real quick. I will stop this and then I will start it up again. Yeah, there we go. So now it starts up happily. Okay, let's see. Let's put this back where it was. And let's come over here and let's reload everything. And let me open up my command line console now. All right, so where am I here? I'm going to open up another tab and I'm going to go into that folder that I just created. Now, I happen to have a few other previous files in here from some other tests that I was doing before, but I'm in my uploads folder. And that is one more thing to consider now. You will likely have to create the folder that you are referring to. Make sure that that folder actually exists before you try to use this web application to upload something. Otherwise, it will likely blow up. All right, so then let's go ahead and try uploading another file. And now we should see that if it's successful, we'll see that file show up in our uploads folder here. So let's see, I will again start by picking a person and let's do Ben Parker. All right, so there's Ben Parker and then we'll add a record for him, Ben Parker, and I don't know, 4/4/1984, and B Parker at photos.com, and a salary of $65,000. And let's see what we get here. Okay, so there's the record there. So we didn't run into any apparent errors. And now here is the moment of truth. What will we have over here? Hey, look at that. There's Ben Parker. Okay. So yeah, so our uploading is now working and we were able to store this file onto our local file system. So all of that is working as expected, okay? So now in the next lesson, let us continue on with fleshing out more of the CRUD operations for the file storage, okay? So we've got it for the person repository. Now let's do it for the file storage itself, right? So when we delete a record from here, we should not only delete the person record out of the database, we will now also have to delete the file from the file system, right? So we've got to kind of maintain what we do in the database with what we do on the file system. So we'll address more of those kinds of use cases in the next lessons. So I'll see you there. Hey guys, thanks so much for watching. If you enjoyed this content and you'd like to help me out, there are several ways you could do that. First, you can always click the like and subscribe. That'll help me out a lot. Additionally, another way you can help me out is to check the link in the description below. That'll link you to my website where you can find additional courses. And finally, for those of you who might be interested in starting a new career as a professional software developer, I offer a free PDF guide that will detail exactly how you can get started in this field with no college degree and no prior experience. All you need to do is click on the link in the description below. Thanks again, and I'll see you in the next one.